Welcome. On this video, we will introduce the idea of a functional equation. So let's get started. Let's start by considering this function. F of x equals 2 to the x. And let's start by evaluating the following. And let's see if this condition is met by this function. So let's start. Well, what is f of 2? All this is saying is that I'm going to go to my function and I'm going to evaluate it by 2. So therefore, I'm going to get 2 to the second, which is just 4. So what exactly is f of z? This is saying go to the function f, and every time you see a value of x, you're going to plug it in with the z. So therefore, my output is 2 to the z. Now for c, we want to find out what f of y is. So f of y, go to the function of f and evaluate it by y. So therefore, every time we see an x, we're going to just substitute it with the y. So we got 2 to the y. Now for d, we want to evaluate it by a whole expression. So now what exactly do we mean by this? Well, this is saying I'm still talking about function f. So that's exactly right here. But the input, it's a little bit different. So therefore, we're going to substitute all x's with the whole expression of x plus y. And notice that we just have one here. So therefore, I'm going to go to function f, and every time I see an x, I'm just going to substitute it with the whole expression of x plus y. So what exactly does that give me? Well, that gives me the expression of x plus y, because all I did, I went to function of f, and every time I saw an x, which is just right here, I substituted with this x with the expression of x plus y. And now, this is our main objective, because this is what we're going to refer to as a functional equation. It is definitely an equation which has an equal sign, but it is an equation where the unknown, it's a function. Because we want to come up with a function that will make this a true statement. But let's see. Do we know exactly what f of x times f of y is? Well, f of x times f of y, we already have them here. I know that f of x, that's equivalent to 2 to the x. And f of y, we already found it here. That's equivalent to 2 to the y. So therefore, f of x times f of y is 2 to the x times 2 to the y. Notice that we have the same denominators, so therefore we can add the numerators. The exponents. So therefore, the expression f of x times f of y is just equivalent to 2 with an exponent of x plus y. Now let's take a look at the right-hand side. F of x plus y. Well, we already found that here. We already found previously that the expression f of x plus y is just equivalent to 2 to the x plus y. And notice that the left-hand side is definitely equal to the right-hand side, because we have that 2 of x plus y is equal to 2 to x plus y. This is a true statement. Anything, it's always equivalent to itself. So is it true that this is a true statement? Well, in this case, yes, it is true. So notice that what we have done is we definitely found an equation. Notice what is the equation that we found. The equation that we used was 2 to the x. And notice that this equation make this statement true. Therefore, this equation is what we're going to refer to as the solution. This equation is the solution of this functional equation. Because again, a functional equation, it's an equation where the unknown, it's a function. So consider this as some kind of a condition. And we want to find out what equation fulfills this condition. And we just found out that the equation 2 to the x fulfills this condition, because the left-hand side is equivalent to the right-hand side under this function. And this is pretty much what a functional equation is. A functional equation is a function, it's an equation where the unknown is a function, and our objective is to find out what function makes this a true statement or what function fulfills this condition. But let's just define it. Let's just define it and let's take a look at a couple more examples. So again, the definition of a functional equation, it is that a functional equation, it's an equation where the unknown is a function, aka the solution, it's a function. Well, let's take a look at a couple more examples here. So let's consider the functional equation. So notice that here we have a functional equation. F of x squared, it's equivalent to f of x times f of x. So this is a functional equation. And our objective is to come up with a function that will make this a true statement. And here we have three different functions: f of x equals log of x, and f of x equals x plus 2. So we want to find out which of these three functions actually fulfills this functional equation. And if it fulfills it, then we know that that's the solution of it. So how do we know if it's a solution? Well, let's take a look at the left-hand side, which is defined as f of x squared. So is it possible for me to find out this value? Well, definitely, because all we got to do is go to the function of f of x, and every time I see an x, I'm going to substitute with x squared. So therefore, f of x squared is just x squared. Perfect. Now, let's take a look at the right-hand side. What is f of x times f of x? Well, f of x times f of x, well, we know that f of x is being defined as just x itself, because that's how we have it here. F of x is equal to x. So every time we see an f of x, we can just substitute with an x. So here we're going to have x times x, which is definitely x squared. So now notice that we end up with the same equation. Let me just choose some red here. Notice that here we have the same equation on the left-hand side, which again, notice that this is the left-hand side, with the right-hand side. So notice that the equation f of x equals x fulfill or made this a true statement. So therefore, this is a solution, because sometimes in functional equation, there's different solutions that we can find out. And since it is a solution, then yes, this equation definitely satisfy the functional equation. So notice that we have a solution. Oops. So notice that we have a solution. We have the solution of f of x equals x. Because again, the solutions right now are going to be actual functions. So this function definitely made this true. But now let's take a look at b. Does the function of b make this a true statement as well? Well, let's find out. But now the function of b is f of x equals log of x. Well, let's take a look at the left-hand side. F of x squared. All this is saying is that go to my function of f, and every time you see an x, we're going to substitute it with x squared. So we have it here. So definitely f of x squared, that's equivalent to just log of x squared. Okay, so that's good. So now what is f of x times f of x? Well, f of x is defined as just log of x. So we're going to have log of x times the log of x, which log of x times log of x, well, that's equivalent to just log of x squared. So now what we want to do is, well, does the left-hand side, is the left-hand side equals to the right-hand side? Well, just be careful here because the rule of log says that if the exponent is inside the log, which in this case is true, we can bring the exponent to the front. So this we can just write it as 2 log of x. But notice that we cannot do that in here because this 2 is an exponent of the whole expression. If it would have been in front of x, I'm sorry, if this exponent would have been on the 2, then we could have bring it down and that would have matched it. But notice that the left-hand side does not equal the right-hand side. So therefore, the function of log of x is not a solution of this functional equation. Because when we just plug it in, the left does not equal the right-hand side. So in this case, this is a no. The function of f of x equals log of x is not a solution of this functional equation. Well, let's take a look at C. Now for C, my function has been defined as just x plus 2. So let's look at the left-hand side. What is exactly f of x squared? Every time we see an x, we're going to substitute with x squared. So definitely my result is x squared plus 2. So on the right-hand side is f of x times f of x. But what is f of x? Well, f of x, it's already defined here. It's x plus 2. So we're going to have the expression x squared times, x plus 2 times x plus 2, which is going to give us the expression of x squared plus 4x plus 4. So now the question that we want to ask ourselves is, well, is the left-hand side equals the right-hand side? Well, in this case, it is obvious that they're not the same. X squared plus 2 is not the same as x squared plus 4x plus 4. So therefore, the equation x plus 2 is not a solution. So in this case, the equation does not satisfy the condition of this functional equation. So out of these 3 possible options, the only solution the only solution for this the only solution for this functional equation is just the equation f of x equals x, because that made this a true statement. Let's take a look at another example. Let me just bring this down. All right. So here we have a new functional equation. So now we have this new functional equation. F of x squared now is f of x plus f of x. So now we want to see which of the following 3 functions are an actual solution of this functional equation. Well, let's see. F of x squared. Well, f of x squared, well, that's going to be x squared. And now f of x plus f of x. Well, I know that f of x is just x. So we're going to have, well, let me just put this parenthesis so we know that they're different. So now that's going to be x plus x, which is equivalent to just 2x. So again, this is my left-hand side. This is my right-hand side. Now for the left-hand side, we have the expression x squared. And for the right-hand side, we have the expression of 2 of x. So does the function f of x equals x fulfills this new functional equation? Well, in this case, no. It does not fulfill, or it just does not fulfill the conditions that are needed for this statement to be true. So therefore, f of x equals x, it is not a solution of this new functional equation. But now let's take a look at log of x. Is the function f of x equals log of x a solution of this functional equation? Well, let's see. What is f of x squared? Well, every time we see an x, we're going to substitute with x squared. So we're going to have log of x squared. But now notice that in here, the 2, it's inside the log, so we can definitely bring it to the front. So this is equivalent to just 2 log of x. So now let's find out what the right-hand side is. So f of x plus f of x. Well, we know that f of x is just log of x in this case. So we're going to have log of x plus log of x. And 1 log plus another log is just 2 logs. of x's. So now notice that here on my left hand side, we have the expression of 2 log of x's. And here on the right hand side, we got the expression of 2 log of x. So now notice that when I use the function log of x, I fulfill this condition. I just shown that the left is equals to the right. So therefore, the function log of x, it's a solution of this functional equation. Now let's just see what's going on under C. So again, we want to see what if it fulfills this condition. So we're going to have f of x squared, which in this case is going to become x squared plus 2. And now we're going to have f of x plus f of x. And f of x in this case is just x plus 2. So we're going to have x plus 2 plus x plus 2, which is this is equivalent to just 2x plus 4. And notice that the left-hand side, it is not equivalent to the right-hand side. So now this equation, x plus 2, it is not a solution of this functional equation. So therefore, the only solution that we have for this functional equation is just the equation f of x equals log of x. And again, this is not the only solution. There are different solutions that can still satisfy this. But out of the 3 options that we were given, this is the solution that fulfills this condition. So therefore, this function is the solution of this functional equation. So let's just do the last example for today. So it states, let's define 2 functions for f of x that will satisfy the functional equation f of negative x equals f of x. So this is my functional equation. So we want to come up with a function that will make this a true statement. Well, one thing that you might notice is that this is actually how we write, well, this is the notation that we use when we refer for even functions. So any even function will satisfy this. So therefore, if I define f of x as x squared, notice that it will satisfy this condition. Well, let's just do it real quick. Well, f of negative x, that's equivalent or just negative x to the second, but any variable, if it's positive or negative, raised to the second, it's always positive, so therefore it's just x to the second. So now notice that this even function, x squared, it satisfies this condition, so therefore this is one of my solutions. Another function that perhaps we could use is x to the fourth, because notice that f of negative x, in this case, it gives me x to the negative x to the fourth, and now we have an even exponent, so therefore any variable or any value, if it's positive or negative, raised to an even exponent, it's always going to be positive. So now this just comes out as x to the fourth. And what we have shown is that f of x, it's equivalent to f of negative x, which is a condition that we wanted to show. So therefore, this function fulfills this condition, and we can label it as a solution of this functional equation. And with this, we have concluded our lesson for functional equations.